Good afternoon, everybody. Here is the long-awaited acetal hydrolysis video. The example that I'm going to use is I'm going to take this dimethyl acetal of benzaldehyde. We're going to react it with aqueous water acid, and we're going to get out of it benzaldehyde and 2 equivalents of ethanol. Keep in mind that this is H3O+, meaning that this is water with a large amount with acid in it, but it's a large amount of water. This is not a catalytic acid process. So let's go ahead and get started. I'm going to start the mechanism. So hopefully, to make things a little more clear, I've drawn the acetal component in red. Our first step is going to be proton transfer from the acid to the acetal. Okay, so now we've got a good leaving group. That leaving group is going to go ahead and leave, and it's actually going to get a little push out. The idea that that carbocation that would be formed is going to be resonance stabilized by that neighboring oxygen helps promote this step. So you can see that we've kicked out our first equivalent of methanol, and we've generated this resonance stabilized cation. In this resonance form, we see that the positive charge is on the oxygen, but if we went ahead and pushed those electrons out, what we could see is that this carbon is very electrophilic, so that's going to make it very easy for another molecule of water to come in and attack this intermediate. So you can see that the water has added. Now we're going to do a proton transfer. And the product of this proton transfer is going to be our hemiacetal. So there's our hemiacetal. For the sake of clarity, I'm just redrawing my hemiacetal down here so we can start working again from right to left. Okay, so now we're going to do another proton transfer, and that proton transfer is going to be aimed towards turning our methoxy group into a good leaving group that we can get rid of. So here's our second equivalent of methanol that we've lost. We're now back to we're to a protonated aldehyde. And a last proton transfer, probably from one of these waters that we made somewhere else in the reaction. Will then get us to our aldehyde product. So here we are at our product. Here you can see one equivalent of methanol. There's the second equivalent of methanol. If we slide up and look at our overall reaction, there's our methanol. Slide us back down here. Here's our benzaldehyde. And interestingly, here is our H3O+, our base, our acid. And remember, this is an acid catalyzed reaction. So here we generated an acid, here we used an acid, here we generated an acid, and here we used an acid. So we used up 2 equivalents of acid, but we generated 2 equivalents of acid. So it is a catalyst. If you take a look in your textbook on page 869, there's a neat little scheme that shows you the acetal formation and hydrolysis mechanisms going forwards and backwards, with the intermediates being numbered. And actually, this numbering could be considered kind of useful. If you are using that interesting little scheme down there, I've gone ahead and numbered each of these intermediates. So if we're doing the hydrolysis of the acetal, we're starting at species number 8, the acetal. We're seeing the proton transfer step, which forms number 7, which is the tetrahedral intermediate. Loss of the leaving group gives intermediate 6. Proton transfer gives nucleophilic attack on 6 gives intermediate 5. Proton transfer gives intermediate 4, which is our hemiacetal. Proton transfer to intermediate 3. Loss of the nucleophile takes you from intermediate 3 to intermediate 2, and finally proton transfer gets you to number 1. Hope this helps out, and thank you for watching.